Today, we are diving into something that is shaking up the world of mathematics: univalent foundations. Seriously, this is a completely new way of looking at the very, very basics of logic and reason. So, I want you to just think for a second about the equal sign. The most basic symbol in all of math. Your whole life, it's meant one thing. This and that are exactly the same. But what if that's not the whole story? What if equals could mean something deeper? What if, instead of just meaning identical, it could also mean equivalent? Now, that might sound like we're just playing with words, right? But believe me, this one simple shift is the key to a revolution that's rewriting the very rules of the game. So, where did this whole crazy idea come from? Well, it really starts with one guy, the brilliant and visionary mathematician Vladimir Voevodsky. He was worried that math was getting so complex, so abstract, that no single human could ever be 100% sure a big, complicated proof was actually right. So he set off on a quest to build a new, stronger foundation for everything. Then, back in the early 2000s, Voevodsky found something astonishing. He found a hidden bridge between two fields that felt like they were on different planets. On one side, you've got homotopy theory, which is all about the study of shapes and spaces. And on the other, type theory, this super logical system, the kind of stuff that powers computer code. They couldn't seem more different. But Voevodsky found these unexpected and deep connections that tied them together. Okay, so when you discover a brand new continent, you need a new map, right? Well, to explore this amazing new connection, they needed a whole new language. And that language is Homotopy Type Theory, or HoTT for short. You can think of it as a hybrid language, one that speaks both geometry and logic at the same time. It was built from the ground up to explore this new world. And look, the goal here was, well, it was huge. This wasn't just some academic exercise. The idea was to build an entirely new foundation for all of mathematics, a more intuitive, more powerful alternative to the set theory that's been the bedrock of math for more than 100 years. All right, so if you're going to rebuild math from the ground up, where do you even start? Well, you start by messing with its most basic rule. And that brings us to the absolute heart of this whole thing, the univalence axiom. This is where it gets really cool. Check this out. We have to understand two kinds of sameness. On one side, you have identical, what mathematicians call equal on the nose. It is what it is. But then you have equivalent. And the classic example here is a coffee mug and a donut. I mean, obviously, they're not the same object. But to a mathematician who studies shapes, a topologist, they're basically the same. Why? Because you can squish and stretch the mug into the shape of the donut without ever tearing it. They both have exactly one hole. They are structurally the same. They're equivalent. And that's what the univalence axiom is all about. It's a new formal law of mathematics that basically says, hey, if two things, or types, are structurally the same, if they're equivalent, we can just go ahead and say they're equal. Full stop. It bakes that donut and mug idea right into the rules of logic. And here's the kicker. This isn't even a brand new way of thinking for mathematicians. They've been doing this kind of thing intuitively forever. Whenever they find two structures that are interchangeable, they just kind of treat them as the same thing. All the univalence axiom does is make that common sense shortcut an official part of the system. And this is where it gets absolutely mind-bending. Because by changing this one little rule about what equals means, this idea didn't just tidy up the foundations. It built this incredible, almost magical bridge between two completely different universes, the universe of pure logic and the universe of physical space. And this just lays it out so perfectly. In this new world, a logical type can be seen as a geometric space. A proof that two things are equal, well, that's now a literal path that you can draw between 2 points in that space. Suddenly, the abstract steps of a logical argument become a journey through a geometric landscape. Logic literally becomes geometry. So what's the big deal? What's the payoff? Well, it's huge. For one, you get a single, unified way to look at all these different areas of math. Your proofs get cleaner, shorter, much more elegant, and, this is a big one for modern math, it's tailor-made for these super high-level arguments about how entire mathematical systems fit together. It's a serious upgrade. Okay, I know this all sounds super abstract, right? Like shapes and logic and paths, but it has a really important, really practical application that brings it right down to earth computers. Yeah, this is not just some thought experiment for mathematicians to noodle on. Univalent Foundations are actually the engine behind a new wave of software called proof assistants. These are programs that can check a mathematical proof and verify with absolute certainty that it's correct. It's how we can finally be sure our most complex ideas are flawless. And you can really see the story unfold over time here. It starts with Voevodsky's big discovery, then the theory gets developed, then we see these massive computer libraries like Unimath get built, and now we have amazing new systems like Coq and Agda, which makes it way easier to do all this stuff on a computer. This thing is not standing still, it's moving fast. So yeah, these are the two big players in the game right now. You've got Coq, which is where the huge Unimath library was first built. Think of it like a giant verified encyclopedia of math. And then you have Agda, which is kind of the next generation, with these special cubicle features built right in to make univalence run smoothly and efficiently. All right, so where is all this headed? What's the end game here? Because we're not just talking about a new trick or a new tool. We could be talking about an entirely new language for mathematics itself. You know, this quote just nails it. For hundreds of years, brilliant thinkers have dreamed of creating a universal language for reason, a common code for all of mathematics. And Univalent Foundations, well, it might be the closest we've ever come to actually pulling that off. So that's the thought I want to leave you with. By turning logic into geometry, by making equivalent the same as equal, are we just giving mathematicians a cool new toy? Or are we actually watching the birth of something way, way bigger, the universal language of reason itself?